Namaste, welcome all. Today we are going to learn about chi-square test and goodness of fit. Let's learn the concept of chi-square test and goodness of fit. Before learning about chi-square test, let me introduce you with a topic called parametric and non-parametric test. What is a parametric test? In certain test procedure, assumptions about the population distribution or parameters are made. These tests, that is, when assumptions are made, the test is known as parametric test. But there are situations where it is not possible to make any assumptions about the distribution of the population from which samples are drawn. In such situations, we follow test procedures which are known as non-parametric tests. That is, in such tests, we cannot draw assumptions about the population in which the samples are drawn, and such tests are called non-parametric tests. And here we are studying chi-square test, and chi-square test is an example of non-parametric test. Okay. Chi-square test is a non-parametric test. Chi-square test is a non-parametric test. Then what is chi-square test? What does it do? Yes, chi-square test describes the chi-square describes the magnitude of the discrepancy between theory and observation. What is done in chi-square test is we compare the observed frequencies in sample data to expected frequencies based on null hypothesis. Actually, this test was developed by Professor Carl Pearson. We all must have heard about Professor Carl Pearson. He's quite famous, right? Professor Carl Pearson had developed this test in 1900. Okay? Chi-square test is one of the simplest and most widely used parametric tests in statistical works. Then let's see few characteristics of a chi-square test. Few assumptions and requirements of chi-square test. In chi-square test, the data points, that is the individual figures in the chi-square test, that is the individual figures that we take in the chi-square test need to be independent. Then, in chi-square test, the sample size need to be large. That is, the sum of total frequencies should be, that is the sum of total frequencies in the observed frequencies table should be at least 50. It should be at least 50. That is, the sample size, if the sample size is low, then the result may be redundant. So a chi-square test requires large sample. Then the expected frequencies should be at least 5. That is the data point expected frequency. In expected frequency should be at least 5. Then what happens if the expected frequency, the data point in expected frequency is less than 5? Then we need to pool it. We need to combine it with the data point before it and after that. Okay. Let's see what are the characteristics of chi-square test. Let's say it out that it is a non-parametric test. Why it is a non-parametric test? Because assumptions about the form of the distribution or its parameters is not required. Then it is a distribution-free test. That is, it has no particular distribution. It can be used in any type of distribution of population. Then it is easy to calculate chi-square test statistic. Okay. Then what does it do? It analyzes the difference between a set of observed frequencies and a set of expected frequencies. Calculating the chi-square test. Yes, how do we calculate chi-square test statistic? How do we calculate the chi-square test statistics? It is done by a formula. What is that? Chi-square is equal to sigma of O minus E whole square divided by E. It is a simple formula. Chi-square is equal to sigma of O minus E whole square divided by E, where O stands for observed frequency, E stands for expected frequencies. We all know that sigma is sum of all categories. Interpreting the chi-square test results. How do we interpret the chi-square test result? We will get a chi-square statistic. We will compare it with the table value with the level of significance. Usually the level of significance is 5%, that is 0.05. If the chi-square statistic is less than the table value, then we accept the null hypothesis. If the chi-square test statistic is greater than the table value, it is outside the acceptance region and therefore we reject the null hypothesis. Then let's learn about the tests of goodness of fit. If we have a set of frequencies of a distribution obtained by an experiment, and if we are interested in knowing whether these frequencies are consistent with those which may be obtained based on some theory or hypothesis, then we can use chi-square test of goodness of fit for this purpose. Okay, chi-square test is used in medical field, in political field, etc. Examples and applications of chi-square test. It is used in surveys, healthcare, marketing, and if for a retailer, if he want to know whether the candy popularity, it is widely used in candy popularity. That is, if a retailer want to know which kind of candy has maximum turnover, he can use chi-square test. Okay. Then what are the limitations and considerations of chi-square test? Yes, we have already said that chi-square test will not work with small samples. It needs large sample. That is, the size should be at least 50. That results may be unreliable with sample sizes, small sample sizes. Then we have already discussed that expected frequency should be at least 5 in each category. Then we already seen that the data points should be independent. These are all limitations and considerations in chi-square test. Then let's see what are the more applications of chi-square test. What are the more applications of chi-square test? It is useful for the test of goodness of it. We have already learned. Then something more is there. The use some more uses are there for chi-square test. It is useful for test of independence of attribute, whether these attributes are independent or not. Whether height and weight are independent or dependent, we can test using chi-square test. Then it is useful for testing of homogeneity. Tests of independence are concerned with the problem of whether one attribute is independent of another, while tests of homogeneity are concerned with whether different samples come from same population. So what is testing? We use chi-square test for testing homogeneity, that is whether different samples come from same population. We take different samples and we test whether these samples are from the same population. We use chi-square test for that. Okay, these are uses of chi-square test. So chi-square test is a very powerful test. It gives us valuable insights of the relationship between variables, and it helps determine goodness of it, and it helps us make evidence. It helps us to make decisions on the basis of evidence. Okay, that's it. Thank you all.